Okay, so after quite a bit of a delay, after some difficult personal circumstances for me, we're finally back to lecture videos for Meteorology 107. And again, thank you for your understanding and my apologies for the continued delays. But to not delay it any further, let's get into this video. Week 5, starting off with heat waves and drought. So, starting right off, heat waves. By definition, it's a period of abnormally and uncomfortably hot and usually humid, going with the heat, weather. And when we say period, that's typically, it could technically just be a day or two, but we usually consider it to be several days to several weeks because that's when you start getting these longer term impacts and it ends up creating a hazard to human health. And there are some specific criteria for this. The World Meteorological Organization considers this to be 5 or more days of prolonged heat that consist of high temperatures at least 9 degrees Fahrenheit above the average high temperatures. The National Weather Service in the United States usually considers a heat wave to be when they issue a heat advisory or an excessive heat warning, and those are typically geared around heat stroke risk, which goes back to, as we'll talk further on in this video, to heat index, typically. If we want to look at the formation of heat waves, how they come about, there's 4 primary factors that go into it. First, we need to have an absence of a cold polar air mass. We don't want cold air anywhere near this if we're going to get a heat wave. That means that the jet stream is going to be well removed. So in the US, that means well to the north. Of course, southern hemisphere, the jet stream, you have to flip it around. But in the US, we get a picture that looks a little bit like this. We get a upper level ridge that's firmly in place with the jet stream far to the north. So we get a very dominant ridge over the region and just to the west of the region where we want this heat wave. Because the other thing that sort of couples in this, and going back to what we talked about earlier, we want a surface high pressure system that tends to form on the east side of the upper level ridge. Because we want the surface or I shouldn't say really we want, if you're going to get a heat wave, that's associated with a surface high pressure system because that has sinking air, as we talked about earlier. And that gives clear sky, which makes it easier for the ground to heat when you have all of the solar radiation reaching the surface instead of reflecting off of clouds. The other thing that helps contribute to the formation of a heat wave is dry ground. And this is because dry air heats up faster than moist air, so the ground tends to influence directly the air that's right next to it. So dry ground means dry air, moist ground means moist air, and dry air heats up faster than moist air. It also means that we have reduced evaporation of that moisture, and that would otherwise lead to clouds, which goes back to point 2 for strong surface heating. And the final of the 4 primary factors that contribute to formation is weak vertical mixing. And this is because it's easier for the surface layer, right, the air right next to the surface, to become warm and excessively warm if it's stagnant, if it sticks around. And that means that if it's shallow, it can do that more easily when we're not mixing out with air above. And again, the reason why it's shallow is because it's heated by the ground surface. So all of these are connected together in that sense. Another view, so this was sort of the upper level big picture view. This pattern that looks like the Greek letter omega is a very typical pattern for heat waves. It's referred to as an omega block. So if you're looking at upper level maps, you'll typically see something like this that isn't just transient, because we'll have ridges and troughs coming through all the time. But if this kind of a ridge forms that sticks around, it's indicative of a heat wave typically in the warm season. If we look instead at sort of a cross-section view, it looks something like that, where again, we sort of have our ridge aloft and our high pressure system near the surface, sinking air leading to clear skies and strong solar heating. So if we want to measure the impact of a heat wave or talk about some actual quantification or number to put to what a heat wave is, the impact or magnitude of extreme heat is typically measured with heat index these days. And that is a combination, an index of air temperature and humidity. And it's an estimate of about what the apparent temperature, what you'd feel in shade based on the impact that humidity has based on reduced perspiration. There are some issues with it. It's just including air temperature and humidity as a measure, but this is what you see all over the place. It's what typically National Weather Service uses in reporting. It's what a lot of your news stations. So this is what you'll typically hear about is heat index, which is a combination of air temperature and humidity. And it's based on impact of perspiration. It's calibrated for humans, but it also represents a measure of the impact on animal life as well. There's a little bit more advanced or complicated measure that's used particularly by military and certain athletic organizations called wet bulb globe temperature. And that doesn't just include temperature and humidity, but because it aims to measure the overall amount of heat stress in direct sunlight, it also includes things like wind speed, sun angle, and cloud cover in order to estimate the full effects of radiation, conduction of heat away from skin, and evaporation from perspiration. Don't have to know the details about this, just it's a good thing to be aware of if you're in an athletic or a military context, because that's where it's used a lot. And this might become more widely used in other contexts in coming years. If we look at impacts and hazards from heat waves, the big one here is heat stroke. Heat stroke refers to excessive body temperature. Usually the threshold for that is considered 104 degrees Fahrenheit, 40 degrees Celsius. And it's really, if you had to give a summary of it, it's the failure of the human body's temperature regulation systems. It's where the ability of the human body to maintain the temperatures it needs for all of its chemical operations, those maintenance systems just start shutting down and failing. And it typically, if it's not treated promptly and carefully, it will lead to death. It will lead to the body's systems failing. And this makes heat waves typically the deadliest form of hazardous weather in the United States. So it's nothing to be trifled with. It's something to be taken very seriously. Heat exhaustion is another one of these impacts or hazards of heat waves. And its sort of summary, its main way of looking at it is a water and electrolyte imbalance due to excessive sweating. Symptoms of this show up as headaches and fatigue, typically. And this can be a precursor to heat stroke if it's left untreated, because if the water and electrolyte balance becomes severe enough, that will lead to the body's natural cooling system through perspiration and its ability to regulate systems shutting down as well. So if you start getting symptoms of heat exhaustion when you're in a heat wave or extreme heat context, take that very seriously as well. Other symptoms, other things that show up in heat waves include heat rash, heat cramps, and very typical thing because people sweat in order to try to cool themselves, natural process, dehydration, which brings us really to safety tips and what to do about a heat wave. And this includes finding air conditioning. Of course, a heat wave, mentioned before, days to weeks on a time scale. So unfortunately, in most places, the infrastructure for electricity means that you shouldn't be running necessarily your air conditioning full blast all the time during a heat wave. You have to be a responsible consumer of electricity and run air conditioning just enough to keep yourself safe. The other thing, avoiding strenuous activities. This is a key measure. Don't be out in direct sunlight and doing things that causes additional heat stress to your body. Wear light clothing so you're not unnecessarily getting effects of solar radiation, warming yourself up. Especially check on family members and neighbors, because elderly populations, especially, but several other different populations, it's good to check up on them because they have disproportionate risk for heat stroke and other impacts. Drink plenty of fluids. Dehydration, again, definitely a cause for a lot of the things that can go wrong from extreme heat. Electrolytes, also something to pay attention to, of course, because those can get out of balance as well. Watch for the symptoms of those definite medical impacts. And a big thing, never leave people or pets in a closed car. It's a very dangerous thing because windows allow solar radiation, the light, to get in, but don't allow the heat or infrared radiation to escape. So it gets extremely warm when you have sunlight and warm ambient conditions like you have in a heat wave. If you're interested in more information, this is a good website from ready.gov. Feel free to check that out. Moving on to drought. So whereas heat waves sort of refer to just high temperature and impacts of heat, drought is more on the moisture side, on dryness. So it's a period of abnormally dry weather that's sufficiently long enough to cause a serious hydrological or water cycle imbalance. And it affects larger areas over longer timescales than really any of the other types of hazardous weather we talk about. So much so that it really almost happens on climate timescales or small short-term climate timescales, things on scale of months. And so some literature refers to them actually as climate disasters rather than just hazardous weather. And big thing about drought is because it's abnormally dry relative to the conditions that affect the normal hydrological conditions of an area, it really can happen everywhere, and it has adversely impacted every region of the US at some point in time or another. It's categorized really three types. All of these can happen at once or just some or the other, but there's three different ways of, I guess, looking at or considering drought. The first is meteorological. That's sort of a direct implication from the definition, is that it's when precipitation or the weather-based input to your water cycle considerations being significantly below normal. So meteorological, low precipitation for a long period of time. Hydrological drought is when you're considering groundwater or stream flow, the actual presence of water there. And that's, if it's significantly deficient, that's a hydrological drought. And finally, we have agricultural drought, where we're looking specifically at soil moisture and crop stress. If those are significantly deficient, or we have high amounts of crop stress due to insufficient moisture, that's agricultural drought. If we want to measure or try classifying our droughts, it's actually hard to pinpoint the exact start and end of what a drought is or when it's happening in a general sense, or even identifying the exact triggers or levels that lead to that start and end. So have to come up with some kind of standardized measure, some kind of index instead. So the scale that's commonly used is the Palmer Drought Severity Index, or PDSI, and that it's really a measure of moisture deficiency on an overall level relative to local climate. So there's a lot of things that go into it, but if you had to just summarize, it's all of these different water contributions: groundwater, stored water, precipitation, evaporation, and runoff all go into this. And the exact scale for it, the typical values are -4 to 4, but you don't always see this exact index. A lot of times the more useful thing is the categorization of drought that can be put out by Drought Monitor. That's a lot of maps that you've seen in past weather discussions or past things that we've had in this class. Those figures are really useful for categorizing drought from abnormally dry all the way up to extreme drought. So if we look at impacts of drought, there's some common impacts. Of course, drought being abnormally dry, the very natural thing to happen is some measure of water shortage. So as common citizen, a lot of times when you're in drought, that's probably the first order impact that you're going to see is needing to pay special attention to water conservation. So because of water shortages, so that everyone can get the water that they need for what they need to do. Wildfires are another common impact of drought. This is another thing where you'll see burn bans as an everyday citizen. This is something that has especially made the news this fall out west in the US. Dust storms, another relatively common impact when there just isn't enough moisture in the soil. It can become dry and dust, and if you get winds, that can be easily lofted and blown around, creating significant visibility impacts as a dust storm. The other thing is for agricultural drought, it means pretty directly low crop yields. So that impacts food supply, both direct food supply of producing crops that go for human consumption and the following impacts that going for animal feed impacting food supply in that manner as well. And we also have some more extreme impacts that we haven't always seen in droughts in the US, but worldwide these definitely happen, and they're important to not ignore because when drought happens, these things can happen on the extreme level, including desertification or desertification, where areas that were not previously desert end up becoming desert climate regions because of long-term lack of moisture, famine, extreme impacts on food supply, habitat damage where different wildlife are no longer able to live and thrive in certain areas because of the severe dryness. If no longer suitable for human populations in the magnitude and numbers that they were, can cause mass migrations, and also for resource competitiveness and ability of access to water and food can even in extreme cases cause social unrest and war. So all of that put together, that wraps up our overview of heat waves and drought. This is a very high level overview of their topics of interest. There are plenty of really good resources online to go look that up, but this course just have time to get into the very basics. Looking ahead to the rest of this week, main comment is that week 4, again, because of circumstances on my end, didn't really have much other than just playing catch up on quizzes and other such things. But this week we're a little bit behind schedule on lecture videos, but everything else is back up and running, and hopefully going forward things will be a little bit more prompt once I get back into the swing of things. So lecture videos will be coming up as sort of a bundle around the same time as this one. Rest of this week, 3 more videos left, all of them about severe thunderstorms. First on ingredients, then on just a general overview behavior types of severe thunderstorms, and then going into impact safety, particular details about hazards. One thing we won't be focusing on are tornadoes. That will end up in week 6 to start week 6 off, as well as some things on flash flooding. That will also be week 6. Discussion post, initial post due Thursday due to a little bit of delay from the usual Wednesday and me getting it up initially. Reply due Saturday. Quiz, that's as usual. And remember that based on everyone's feedback, made some adjustments to that. Now you have 20 minutes instead of 15 minutes as the standard time. And you also get 2 attempts to do it. So you should get some kind of feedback on your responses, on your incorrect responses on your first attempt. So hopefully you can learn from that and do better on the second go around. And finally, the final project details have also been posted. Please go check that out. As a reminder, that's due at the very end of the course, at the last minute of finals week. So check out the details on that, the rubric, and feel free to send me any questions on that as well. I'll probably be updating that page over the coming days and weeks for any extra resources that you may want, especially if you want to focus your project on something that hasn't been covered in lecture by the time you want to start working on the project. You'll have to go off of external resources instead of class resources for that, which is totally good. If you wanted to make that a little bit easier, or to make that a little bit easier, I'll plan on probably putting together some resources as I get the time to do so later on. Enough rambling about all of those forward-looking details. Hope to see you shortly after this for our severe thunderstorm series of lecture videos. Thank you.